This lecture is going to be the first in a four-part series on something called transformations. Right? And the basic idea here is that if we take a function and then we make a change to it, what effect does that change have? Right? For example, if we start with something like f of x and then we double it, you'll get 2 times f of x. How do these two functions differ? Right? Maybe we look at g of x compared to g of x plus 1. Say, how do these functions differ? That's what we mean by a transformation. And we're going to do this, like we've done a lot of our previous discussions about transformations, about functions, by focusing on the specific impact that these transformations have on the function's graphs. So I want to start with these two functions here. F of x equals x squared and g of x equals x minus 1 squared. So first, I want you to notice what I did here, right? G of x is equal to f of x minus 1. Because remember how we evaluate functions like this. F of x minus 1 says, go to the f of x function, the f of x formula, replace the x in it with x minus 1, and there's your new function. All right, so I want to do this by comparing the graphs, and I want to encourage you to kind of experiment with this a little bit on your own. So what I'd like you to do first is try to graph both of these functions. I want you to do both of them on the same set of axes. So you really do almost have one of them. They're obviously not going to be the same, but you've got the two of them really side by side for the basis of comparison. And if you had to do this by picking points, right, like back when you first started learning about graphing the equation of a line, that's fine, right? Pick some x values, calculate the functional values. Remember, this is the f values and the g values. There's going to be your y numbers. Plot the two of these side by side and see what you come up with. All right, so this is my response to this, and I didn't actually draw the curve between them. I just drew a bunch of isolated points, right? Because it really is the points that I want you to focus on. All right, so let's actually look at some specific numbers. All right, when x is 1, f of x is 1, right? Where is that point? So let's see. The green curve, the outer one here, this is the f of x curve. And this inner one here, that is the g of x curve. Now I want you to think for a minute, what x value in the g function is going to give me 1 for my y value? Well, if you experiment a little bit, if we put 2 in here, 2 minus 1 squared equals 1. So this point that was right here has gotten moved. Right? It's gotten moved 1 unit to the right. And if we try this again with let's say 2, right? F of 2 is 4, but g of 3, and you can confirm this if you made a little table or just by looking at the functions, g of 3 is 4. So this point that was right here got moved over 1 unit to the right. Now if you kind of step back and take a look at the graph as a whole, you can kind of see that happening. Every one of these green left-hand dots, if you were to push it over 1 unit to the right, you would get a corresponding dot on the other curve. So this is the effect of this transformation. Replacing x with x minus 1 had the effect of shifting 1 unit to the right. I want you to really think about that for a minute because it's a little counterintuitive. I know. You've got a minus sign in there, right? You did x minus 1, and we're really accustomed to thinking of negatives as meaning go to the left. right? But here we're actually seeing the reverse, replacing x with, if we want to generalize, right? If you replace x with x minus a, that shifts a units to the right. And what if you do the reverse, right? What if we replace x with x plus a? Well, you can experiment with this if you like. You can try graphing a second function here, a third function, h of x equals x plus 1 squared, and if you do, you should see the reverse. This shifts a units to the left. And the name of this side-to-side shift is called a translation. So I've got two more functions here. F of x equals x squared, which is the same one we had on the last slide. And g of x equals x squared plus 1. And again, I want you to think about what I did here. G of x is equal to f of x plus 1. I'm literally just taking every f value and adding 1 to it. All right, so I'd like you to stop again, right? See if you can graph these. Then come back and we'll go over them together and see what effect that had. All right, so again, I've got my two graphs here, and I just did individual dots. And let's see what's happening. And again, let's pick a couple of points just to highlight. F of 0 is 0 squared, which is 0. And g of 0 is 0 squared plus 1, which is 1. So this point that was at the origin got pushed up to 0, 1. And let's see, let's maybe try one more. F of 1 is 1 squared, which is 1. And g of 1 is 1 squared plus 1, which is 2. So this point that was right here has now gotten moved up 1. And again, if you take a step back, look at the graph as a whole, you see that that's what's happening here. Every point got pushed up 1 unit. This is also a translation, right? Although this is a vertical, an up and down one, where the previous translations we saw were horizontal, they were side to side, right? Ultimately the same thing. Any transformation that moves a graph horizontally or vertically, strictly side to side or up and down, without distorting or changing its shape in any way, is what we mean when we talk about a translation. And I've summarized those results here, right? These two are horizontal or side-to-side translations, and these two are our vertical or up and down translations. All right, so we've got some more of these to go. In the next lecture, we're going to look at a second class of transformations. We're going to talk about the ones that are called reflections.